Hello. Hello, we are group 9. The topic we did is Mongo. So first of all, is the crawler as the part one. For our function, basically, we the input for our function is a n as the index, the frontier as the link set, and the visit also a link set, a work dictionary, and it returns a work dictionary. So basically, what we did is, first of all, we checking the n is valid, which is this part. If n is 0 or not. Uh, wait, just for a second. And then it finds the unvisit link, and it add each part of link to the visit part. Then it returns a dictionary. So basically, it's like using the link set truth to find the frontier, to find the link set we haven't visited yet, and then split them into link and link site, which is the these other parts we haven't visited, and then insert the visit to the link, which is the part we have visited already. And if then we have to check the link, get a page of the link. If we have found that link, if we haven't found that link, we do nothing, just like recursively done, and use our new update visit link to pass in the crawl function. If we haven't visit the list yet, uh, oh yeah, and then that means that we have to update the dictionary and the frontier. And after we update them, in the update function, we have like to do two stuff, which is first add link to the word dictionary, which is means like add a page to the dictionary. Then we have to add the part we haven't visited yet to the link site. After all, we have to like a passing down with the n minus one. But with that means like a recursion to like a to recursive down to find each part. So for the running part is like this. Make this go paste. Yeah. Then we pass the local part in, yeah, right here, and we can do some search. Yeah, it shows up right here. Okay, and that's all for the part one. Then the next part is for the set part. So the set part is for our part B, which is the dig set. Basically, we have like create our own signature for the module D. We basically like use the array function name from the comparable, which is like something like here. There's like a generate key, generate random, which is like mostly from comparable with right here. And some of them we checked the dictionary part. I think there's a compare stuff. Uh, yeah, we check the dict argument and to find out what else we left and to implement them as to make the method better. Then the next part is the actual the stuff, the function inside of the set. For this signature we get from the set, which is right here, such as the empty is empty, insert singleton union, intersect, remove member, choose fold, and for our result is right here. So pretty much like arrays, not like arrays, but majority of them we just like using the D insert, using the function from D, which is right here, module D, and we use that to help to do our function, such as for insert we just like use D insert. For singleton we just using like D insert, and I'm insert into an empty set and fold and something like that. And for our test case, we have like tested almost everything. The first thing we do is we generate a list of the keys. Then we generate a dictionary, which is a key and value. Then for the insertion part, for the testing insertion, we first generate 10 elements. Then we insert a key into the base, and right here we create a new insert dictionary, which is insert a random the element from the random dictionary into empty, and checking whether the every key in the random dictionary is a key of the new insertion dictionary. For the remove, we did like same thing, and we it kind of like we generate a random dictionary and generate the dictionary with the delete dictionary and checking whether the element in the delete dictionary is not a member of the random dictionary. Is not. So we use other to checking is not other not to checking. Then for empty, we just like checking the empty is empty. And then for singleton, we just checking the we create one element and passing and use singleton to create a dictionary and checking whether that is an element of the dictionary or not. So which means if the return key is same as keys return and is now empty and is not empty, so it's then means like we have the correct stuff. Then is union. Union like we just are creating two different size, different random dictionary, and use the union function to union them together, and using our new dictionary, new union dictionary, like to checking if the element in the new dictionary is either in the random dictionary 1 or random dictionary 2. So if there's no false, like I mean, since our function passive means like the element is either in one of the dictionary or the intersect, which is the so pretty much similar like the union. We create two random dictionary and we intersect them. Then we check the element that is in both the random list 1 and the random dictionary 2. And the member is just like testing the member. So here's our test. So I have to start this make clean first. List make. Yeah, so I just have to make everything and save it. My set. Yeah, we can see there's no arrow out, so it basically means we pass every test we create. The next is the dictionary part, which is the most complicated part for us now, which is the like a tree. It's pretty like a 2/3 tree. So the first function we create is as the instruction is the balance. Pretty much for balance is we have 5. I believe it's 5. Oh yeah, we have 5 cases. It's if the dictionary we pass in is a leaf, then it just return true since it's leaf. If the dictionary we pass in, if the tree we pass in is like have 2 leaf on right and left, that means it is a balanced tree, so it's balanced. If the 3 tree is is there has 3 leaf under the nose, that also means true if like since the it does not it has like all the leaf under the nose under the parents, so it means true. And these two parts are like recursive to go down and checking if the left is a leaf or if a right is a leaf. since the left and right are not maybe not leaf anymore. Maybe they just two trees. So if one of them is a leaf, the other side is a tree, that means no balance. So you pretty much like this. If right hand side is a leaf or or left hand side is a leaf, then return false. Else then recursively go down to check like both of them. For three part is also means the same thing. Then as the instruction said, is check the member. Let me see. Member. So pretty much I give a key and using lookup function to go down to find the member. If lookup function does not return anything, just like return none. If does return something, some value, then it means true. Oh yeah, lookup function and the fold function. Fold function is pretty much like the normal. Fold function is pretty much like the fold we used, but it's more complicated. Yeah. It first like fold the middle, then fold the right, then fold right, then fold left, then fold the right. But this one is also means the same thing. It first fold the U part, which is the base case, using this passing as this one as base case. Then fold the K1 V1, then do fold the as this one to do the K2. No, not K2 V2. You just like go straight down to the left, middle, and right. Then is lookup function. So it's pretty much like the find function in the binary search tree, which is a compare the key. If it's a two tree, it compares with the key and value. If it's a three tree, it compares with the key one and the key two. If for the two part, if it's less than or equal to the if it is equal to the key k, which means that key equals to the k, it means that we just return some value, which we found our desired value. If less, it just goes down to the if less than, if we go down to the left part. If greater, we go to the right part. For the three part, it's just like it's like same thing. With it's like if it is less than K1, we go to the left part. If it's greater than K1 and less than K2, we go to the middle part. Then if it's greater than K2, we will go to the right part. Then what else? Let me see. Insertion down, up and down. For insertion up and down, insertion upward, we use the handle a lot. And so basically, we just follow the structure of the handle since the input and handle are pretty similar, and that handle is really helpful for our project. And let me see. Oh yeah, if it is two nodes, we just like grade it to three. With done since it's upward, so it means like there's no leaf anymore. So we just are creating our new structure of this part and pass back to the function that call it. If it's a three part, we just like reconstruct our tree, make these three nodes into two of the two nodes, which means like there's like a two nodes on right, there's a two nodes on left, and we combine them into new structure of tree. And for insertion down, this one is the general case, which is checking if a leaf or a 2 or 3. If it is a 2, it goes to use insertion down 2. If it is a 3 nodes, we use the insertion down 3. With insertion down 2, we check it. It is pretty like the middle of the recursion function for the balance tree. If the which means like it check match with the insertion down, and if the return value is a tree, is like a what's that? Is a tree with a left and right, we reconstruct the tree. If it's just a tree, we just done with it and connect with the two tree. And for the insertion down right is the same. And for the insertion down 3, it's pretty much similar to the insertion down 2, which means if it's the return, we checking the return value. If it's a up type with left or mid key and right, we just like reconstruct the tree. And if it is a down value, we just are using return a down part, down nodes, which is 3 with our new tree. No, it's not our new tree. It's our the tree after reconstructing. So basically this. Oh yeah, remove. The remove is also like pretty much from our handout. So we for every time if it is a if we need to use if it's like a two leaf on the right and left, we use home, and if not, we use absorbed, and I think that's pretty much for the tree. Yeah. So here's our testing part. Make. Yeah. So we use our tree. It's called big. Yeah. So everything pass, which is for the. Just want to show that is like we use our BT dictionary as our testing. So it pretty much means that this test we all passed. And for the last part, which is the fifth part, I think we now have it. So right now I'm going to show the how our program looks like. So I bring this one. No, paste. Yeah. This is the testing for the part 4. And we use the right here. And we can search some key from here, such as zones. Right here. This one, which is right here is Germany something about Germany right here. And what else we can search? Search YYY. Yeah, so we use with YYY, we've got a Sweden. So it's right here. And that's pretty much it. We haven't done the part 5 because we have just spent couple like a long time on it, but we haven't got figure out how to solve it. So that's it. Thank you.